Okay, so let's do another one. A piston cylinder device initially contains saturated liquid vapor mixture of water at 800 kilopascals with the liquid and vapor volumes equal to 0.004 meters cubed and 0.95 meters cubed respectively. The mixture is then heated at a constant pressure until the temperature rises to 250 degrees Celsius. Determine the initial temperature, total mass of water, final volume, and pressure. So remember, it's a piston cylinder device, so unless the piston is obstructed, we're going to have a constant pressure. That's what they say here, the heated at constant pressure. Now, we know that initially we're a mixture. They say that it's a liquid vapor mixture. And they also tell us the volumes of each component being liquid and vapor. So let's have a look at the tables for a second. Where's my pencil here? Let's have a look at the tables for 800 kilopascals mixture. So let's go further down, no, further up. So sorting through by pressure, we're looking for 0.8 megapascals. Great. So this line here is going to have the information we need. So, well, first they ask for the temperature. Well, that's simple enough. It's right here. And we're told it's a mixture, so we don't need to do that check with the specific volumes. We're already told. Now, if we, on the note of specific volumes, we're not told the quality, but we're told the volume that each component has. And if we know the specific volume that each component has as well, we can find the mass that each component has, and then we can add it to find the total mass. Okay, so remember, mass is mass is volume divided by specific volume. So let's write this down here. So mass is volume divided by specific volume. Now we know the volumes, right? And we know from the tables the specific volumes. So let's do mass of F is equal to the volume of the liquid component, which we're told, right? That's going to be 0.04004. Divided by the specific volume of a liquid in that state, which if we get from the tables, we can see it's 0.001115. 0.01115. All right, and this will give us the mass of water that we have, which is 3.59 kilograms. We have some vaporized water as well, which is that volume. Sorry, I should be more specific. Okay, that's an equal sign out of 2. So that's the volume. Again, it's 0.95. Okay. Divided by the specific volume of the gas. So now we're looking at this guy here. It's 0.2404. So 0.95 divided by 244 is giving us a mass of 3.95. 3.95 kilograms. So they ask for the total mass, which is just the sum of those two. So that 3.95 plus 3.59. And it's giving me 7.54 kilograms. 7.54 kilograms total. Now the temperature we read off the table, we can write it down here just to be complete, which is 170.43. All right, what else did they ask us to do? Mixture is heated at constant pressure until the temperature rises. Determine the initial temperature, total mass, okay, and the final volume and pressure. So now we're at 0.8 because we know it's constant pressure. We're still at 0.8, but now we're at 250. So let's go see if that puts us in the superheated steam. That's probably going to put us in the superheated steam. So let's see if there's an entry for 0.8 and 250. So here we go, 0.67, oh, there it was, 0.8, 250, excellent. So we're right, it is a superheated vapor. So let's just, here we go. So they want the volume, great. We know the specific volume is this first column, 0.2931. So if they want the volume, all I have to do is multiply that by the mass, which we just found. So 0.2931 times whatever the volume, the total mass was, 7.54. So we can find that the final volume is just mt times the volume, the specific volume 2, which we found from the table. And that comes out to 2.21 meters cubed. And they also want the pressure. Not the pressure. Sorry, what do they want? Heated at constant pressure. Oh, they want the pressure, but okay. What's the pressure? We already know the pressure. The pressure hasn't changed. The pressure is the same. It's P1 equals P2, which is 0.8 megapascals. So that's the solution to this one.